This technology is HEPA filtration. HEPA stands for High Efficiency Particulate Air, and this filter is regulated to remove a minimum of 99.97% of 0.3 micron particles. Now, to put that in perspective, the average human hair is about 50 microns to 150 microns in diameter, and the limit of your vision is approximately 30 microns. So the filtration occurring in this filter is happening on a precise microscopic scale. Science does have the odd eureka moment, but most of the progress is made through decades of methodical research. The filters we now find commonplace on commercial flights have over 70 years of continuous development and improvement behind them. In fact, the first HEPA filters were developed back in the 1940s under a US government contract. And by the 1950s, when there was industries such as electronics, computing and healthcare provision mandating higher levels of filtration, the HEPA filter became more widespread and commercially available. One of science's greatest strengths is collaboration, something Pall has always embraced. In the 90s, when airline operators were concerned about the spread of microbial contamination in the cabin, the aircraft manufacturers approached Pall. With our engineers and researchers committed to solving this commercial imperative, together we developed the first HEPA-rated cabin air filter for commercial aircraft. Additional milestones were reached in the late 90s when Pall HEPA filters were validated for virus and microbial removal, and again in the early 2000s when the same verification was carried out on our used filters. Our commitment has paid off. Our filtration pedigree has earned us the trust of aircraft manufacturers and operators alike. So where does the air that we breathe in the cabin actually come from? Well, generally it's from one of two locations. It's either the auxiliary power unit, which is a small engine located at the rear of the aircraft, or when we're in flight it comes from the main engines. A small amount of air is taken from the main engine, is channeled through the wing and down here into the air conditioning pack, where it's brought to a condition much more suitable for the cabin environment. This air flows through this duct and into the main ventilation system, which on this A320 is located in the front cargo hold. Let's go and take a look. So here we are in the front cargo hold of an A320 aircraft, and I'm going to show you how the air that you breathe in the cabin is actually filtered. Alongside me you can see one of the HEPA filters installed on this aircraft, and just behind me there's the second filter. Now these filters will remove bacteria and virus with a minimum efficiency of 99.993%. And when we combine that with the fact that the air in the cabin is changed every 2 to 3 minutes, we can ensure that there's a really high quality of cabin air. Now, these filters are designed to very specific standards, and every aircraft has a bespoke design. And we can find that on some of the larger aircraft there can be up to 16 of these filters installed at various locations. The air that's been filtered by the HEPA filters is mixed with fresh air and then passes into the cabin through a set of vents in the cabin ceiling. This air exits the cabin through vents in the floor. So what's so special about HEPA filters, and how do they differ from other kinds of filter? A simple filter might be a mesh screen, where the particles are simply too big to pass through the openings. A HEPA filter, on the other hand, is a dense mat of fibres. Within these fibres, there's 3 different mechanisms of filtration. The first is direct interception. The particles are simply too big to pass through the paper. The second is inertial impaction. This is where the particles are small enough to pass within the structure of the HEPA paper, but they soon come into contact with the fibre where they'll remain trapped. The third mechanism is diffusional interception. Now this one is slightly counterintuitive in that the very small particles start to behave more like a gas and exhibit a very chaotic motion, known as Brownian motion. The smaller the particle, the more pronounced the Brownian motion, and therefore the higher the probability the particle will impact a fibre and remain there. Now these three mechanisms combine together to give us really good removal across the whole range of particle sizes, including virus and bacteria and other contaminants we often encounter in the cabin. Interestingly, as the filter becomes older in the cabin and it becomes more dirty, so the filtration efficiency actually increases. We remain focused on development, continuing our research and collaboration with aircraft manufacturers and operators. We've developed the next generation of HEPA filters. The Advanced Cabin Air Filter, or ACAF for short, introduces an additional filtration technology that will tackle the issue of odours in the cabin. And this journey isn't over. You can relax, breathe easy and enjoy your flight knowing that while you jet towards your destination, Pall scientists like me are already working on the next generation of air filters.